Hi everyone, this is Vlad. In this video, I want to show you a different kind of sample size calculator for your A/B tests. This one works backwards compared to how a traditional calculator would work, and some of you might find that much more intuitive. So for example, it doesn't ask you to put in your power or the effect size you're after, because it assumes you're exploring and you haven't tested this before, and so you don't really have a good idea of what the effect size will be. That's part of what you're expecting the calculator to tell you. What is possible. So instead, it just asks you for your conversion rate and your traffic. Pretty straightforward. And then it gives you several possible effect sizes that you can reasonably expect to detect on your site, and your chance of success for each outcome. So let's see how this works. Let's say I want to run a test on my home page, and about 5% of people make it from the home page to a purchase. So that's my 5% conversion rate. And let's say I get 5,000 visitors per week to the home page. So that's my traffic. And I'll run the report with those settings. And at the top, you'll see your preliminary estimate. And what this estimate tries to do is to balance your testing duration with the effect size that you will be able to detect. So it'll try to keep the duration as small as possible, capping it at 8 weeks regardless. And then beyond that, it'll try to make sure that you can detect at least a 15% effect. That's sort of the minimum that the report assumes. So if I scroll down to this first section, what if there's a true effect, you can see that my projections for that effect size are exactly that. I have 6 weeks, and with that, if the effect size is 14%, then I have pretty good chance of detecting that, 80%. That's our 80% power. That means that if I ran this experiment 20 times, 16 out of those times I'd actually get a statistically significant winner. And then it also gives me other effect sizes that are within the realm of possibility. Once I have my estimate, what I can do is start to play around with my duration, so I can increase the duration to reduce the effect size that I can detect. So now I can detect smaller effect sizes. Or I can go down in duration. Let's say I have to fit into my 2-week constraint for whatever reason. Let's say that's how much I have available for this test. Then I can see what I can expect to detect with that duration. Now the advantage of this report is that it doesn't just give you a single estimate, one effect size. It gives you a range of reasonable what-if scenarios. And that's because we might have little idea what the effect size might be, but I see that if my new version is 10% better or 10% worse, then there's only a 50% chance, 10 and 20, that the effect will actually peek through the noise strongly enough. But if the effect size is as high as 14, then I have an 80% chance of success. And I can then use my judgment to see, if whatever I'm testing can reasonably beat the existing version by at least 10% and ideally 14%. That might be hard to gauge, but at least I see the range, and I can use my knowledge of how big my idea is that I'm testing, my previous experience with similar tests elsewhere, how bad the starting design is, and so on. I can use that information to see whether I can reasonably expect it to do that well. And if the answer is no, then I might reconsider testing that. Another piece of information you can get here is a sense of what the actual observed effect might be. Now remember that even if my new version is 14% better, and I run the test and it's a success, it doesn't mean that the effect size will actually be 14, right? By chance, it may be inflated or deflated. So here you can also see the margin of error. So just by hovering over it. And this means that if I get a 7.5% lift, I know that the true effect might actually be as high as 14, right? So any effect sizes that I observe in this range are consistent with a true lift of 14. On the other hand, if I see, a 3% effect, I know that the true effect is going to be at most 10%. Because if the effect were 10%, then this is the range with this sample size where I would expect the actual effect size to end up. Now let's say I am kind of hoping or aiming for a 14% true lift. I might wonder, if the true effect actually were 14%, what would I expect halfway through the test, let's say? What would the actual observed effect be? Would it be consistent with my goal? And to see that, I can just reduce my duration from 6 weeks to 3, so halfway through. And now I'm going to find the 14% effect, and I see here that this might actually show up as anything from 4.5 to 23.4%. Halfway through the test. So if I'm hoping for 14 and halfway through the test I see something like 5, it's still consistent with what I'm aiming for. So I could keep the test running and hopefully that is the result I could get. But even if the test is not successful, I could use these projections to gauge whether the actual outcome, even if it's not what I wanted, is still consistent with what my hypothesis is, and that may give me some reason to, let's say, give that test another shot, to retest it. Now, so far, I assumed that there is a true effect. It's just a matter of detecting it and how big it is and how it's actually going to, vary due to chance. Is it going to be slightly inflated or deflated? But it's also possible that I'm wrong and my new variation actually produces no effect. In that situation, I might still get a lift, and that's called a false positive. And this second section of the report, what if there is no true effect, allows me to consider that possibility and what I might expect. In this case, let's put it back up to 6 weeks. And we see that with this duration, we have a high chance of a false positive of 5%, positive or negative. Remember that the term false positive includes effects in either direction. And here I see that there's a small chance of a false positive as high as 10%. And the probability of that is about 5%. So it's small, but certainly possible. And if I'd like to eliminate that possibility altogether, then I can increase my duration in this section. Let's say we'll go up to 9 weeks. And now I see that I've reduced the probability of if there is no true effect, the probability would only be 1% of a false positive this high, right? Minus or plus 10%. And now if I scroll back up to the what if there is a true effect, we also see that if there is a true effect, then with this sample size, I can detect smaller effects. So in the end, whatever happens, you have a much better idea of what to expect with using this kind of sample size calculator. So give it a shot. Let me know how you like it. And thank you for watching.